Hello, ladies and gentlemen. We are continuing our discussion on how we are solving log equations, and the examples in this lesson are meant to demonstrate a couple of things. One is we definitely need to check for extraneous solutions whenever we are solving a log equation. Occasionally, throughout the process of solving a log equation, you will see negative numbers that turn up as answers. And sometimes they work, but more often than not they don't, because they would lie outside of the domain of a logarithm, which the domain of a logarithm is all positive numbers. Now, the way that we're going to solve these equations, well, first of all, they're going to have three log terms, meaning I'm going to have two log expressions on one side of the equal sign and a single log expression on the other side of the equal sign. And we're going to take the two that are together and condense them using our properties of logarithms, meaning that if they are multiplied, or if the logs are added together, we'll multiply the log expressions, and if the logs are subtracted from one another, we'll divide the log expressions. Okay, so let's go ahead and take a look at an example here. So here we have a log equation where the two logs on the left side are subtracted from each other and is equal to the one log on the right side. Now all of these have a base e, and so to take the two on the left and condense them, we're going to, because of the subtraction operation that says to divide the log expressions from each other. So I'm going to say the natural log, and because 6 was, the natural log of 6 was the first term that was written, that gets put in the numerator. And since we're subtracting the 5 minus r from it, that gets put in the denominator. And that is equal to the natural log of r plus 2. Now at this point, because the equation has been condensed into a single log on both sides of the equal sign, and they are logs of the same base, we don't need to write the log anymore, and we can just say 6 over 5 minus r will be equal to r plus 2 and solve for our variable like normal. So what I would do to get the expression out of the denominator on the left side is multiply 5, and I keep wanting to write that backwards for some reason. So if we multiply 5 minus r to both sides, okay, the 5 minus r on the left side, those simplify to just be 1, and I have 6 is equal to, well, here we have to distribute. We're basically foiling these two things together. So let's say r times negative r is negative r squared. R times 5 is a positive 5r. 2 times negative r will be minus 2r, and 2 times 5 will be a 10. So simplify our like terms on the right side. So that would be a plus 3r plus 10. And you can see clearly we have a quadratic expression that we're dealing with here. So in order to solve a quadratic, we're going to put it in standard form. We're going to put everything on one side of the equal sign. Now what I'm going to do is I'm actually going to take everything that's on the right side of the equal sign and move it to the left side, because I want my leading term, the r squared, I really want that to be positive. So I'm going to subtract everything on both sides of the equal sign. So plus r squared minus 3r minus 10. And everything on the right side of the equal sign cancels out and gives me 0. And on the left side of the equal sign, I'll have r squared minus 3r minus 4. And at this point, we will simply take the quadratic expression that we have and factor it. So the factors of 4 that can add together to give me a 3 are really going to just be 4 and 1. So I'm going to say r minus 4 and r plus 1. And if I set both of those factors equal to 0, the one on the left is going to give me a positive 4, and the one on the right is going to give me a negative 1. So sometimes when we see a negative solution, again, we have to, first of all, we need to check it anyway. Do they work? But a lot of times when we see a negative number as an answer to a logarithm, we're going to say, oh, well, that's probably not going to work. It's probably going to be outside of the domain of the logarithm. So let's check the 4. So we're going to check 4 here, see if that works. And I'm going to say the natural log of 6 minus the natural log of 5 minus 4 equals the natural log of 4 plus 2. And you can see everything in the parentheses of the logarithm will give me positive numbers, so that's a good sign. So we have the natural log of 6 minus the natural log of 1. Let's make the 1 look like a 1 equals the natural log of 6. And the natural log of 1, if you just type that into your calculator, that's 0. So that gives us the natural log of 6 being equal to the natural log of 6. So everything balances on the left on both sides of the equal sign. So 4 is a good answer. Okay, well, what about the 1? Let's check the 1. Let me get a different color here so they don't blend together. And I don't know, let's try yellow. So let's check the negative 1, see if that also works. Because again, more often than not, the negative numbers don't because they're outside of the domain of the logarithm. But let's check it anyway. So we'll say the natural log of 6 minus the natural log of 5 minus a negative 1 is equal to the natural log of negative 1 plus 2. So let's see. Okay, so on the left side, natural log of 6, and in the parentheses here, that's going to give us the natural log of 6 again. And I don't know why I put that one in parentheses. I guess I'll just put everything in parentheses now. And in the parentheses here, we get the natural log of 1. Okay, so now you can look at this one of two ways. And again, let me make the 1 look more like a 1. Natural log of 1 is 0, and natural log of 6 minus natural log of 6 is also going to be 0. So 0 is equal to 0, so that worked out as well. So in this case, this is one of the first examples that we're seeing where we're actually going to have two good solutions for a logarithm equation. Even though the negative number worked out as an answer to the quadratic expression generated by working the problem out in the first place, it is inside of the domain. But you may want to think about it like this. It's like, well, 0 is outside of the domain of a logarithm. So maybe we would say that that's still an extraneous root, but it looks like it works. So we'll just go ahead and say that for sure this one, and we'll say maybe on that one, because I really don't know if we're going to have two equation or a logarithm equation that has two solutions to it. But mathematically, it looks like it works out. But here, remember, the domain of a logarithm is from 0 to positive infinity. So we have to be greater than 0, not equal to 0. So we'll look at this as probably being extraneous. And that part of my board doesn't read very well. Okay, so let's look at our last example here. Here we have the log of 1 minus x plus the log of x is equal to log of x plus 4. Now, again, the plus between the two logs, that says to multiply the expressions together. And so to condense the stuff on the left, we're going to get log of 1, we'll say log of x times the 1 minus x. And on the right side, we just have log of x plus 4. So multiply by distributing the x into the parentheses, and I will get log of x minus x squared being equal to log of x plus 4. And again, the logs, we've simplified it so we have a single log term on both the left side and the right side. And now, because the bases are the same, we no longer need to write the logs. We can just say the expressions are equal to each other and solve for x like normal. Now again, because we have something that has an x squared for it, I'm going to want to put it in standard form, meaning, and I want my leading term to be positive, so I'm going to take the stuff on the left side and move it to the stuff on the right side. So we'll say plus x squared and minus x, and everything here makes 0, and so here I get the x's on the right side cancel each other out, and I get x squared plus 4. Okay, well, so let's x squared plus 4. Because the b term is missing, we'll just move the 4 from the right side to the left side, subtract 4 from both sides, and I'll get x squared is equal to negative 4. And I see a problem with this, is that if I take the square root of both sides, I'm going to wind up taking the square root of a negative number, which our previous studies with polynomials said that, yeah, I could, because we worked out a quadratic expression while we were trying to solve the logarithm, it should have two answers, but there's nothing saying that those answers have to be real. So when I take the square root of a negative 4, I get a positive and a negative 2i, and those are not real numbers. So in this case, there is no solution to the log equation that we see here. So again, we want to be able to check to see what kind of solutions do we have. If working out the process, we see a quadratic expression being formed, we will have two answers, and we have to check to see if any of them are going to be extraneous or not. And from there, we just say, okay, well, let's check to see if it's inside the domain or not. But again, as you watch the video, if you have any questions, make sure you're writing them down, bring them to me in class or in tutoring, and I will be happy to work with you. But thanks for watching, guys, and we'll see you soon.